Hello and welcome to Cannon County High School Algebra 2. This is another in our series of videos designed to help those of you who did not pass third quarter do a little bit of makeup work so that you can get your third quarter grade up to passing. Today we're working on L.5, so Mr. Lyon, you're going to have to watch from over there again. Thank you very much. Today on L5, what we're doing is we are simplifying radicals. And that sounds like fun because it is. The first one that we're going to do, let me zoom in a little bit, is the square root of 1024. And you remember that what we're doing is trying to find perfect squares that can come out of that square root. Now, what's the square root of 1024? I don't know either, so I'm going to use a calculator. So on your calculator app, that's the Calculate 84 app, download that if you don't already have it. We're going to take the square root of 1024. And how about that? It is a perfect square, it's 32. So that means the square root of 1024 is 32. And the square root of x to the fourth, well remember, on a square root there's a little invisible 2 right there, and basically all you do is you take the 4 divided by the 2, and you get x to the second power. And that's it. Let's try another one. The cubed root of negative 54 times x to the 9th power. Okay? Well, again, let's try to see if negative 54 is a perfect cube. And the way you do that is you take negative 54 to the 1/3 power. So let's do that. Negative 54 raised to the 1/3 power, because that would be the cubed root. And unfortunately, it is not a perfect cube. So that means we have to do a little bit of work on this. You want to try to break this 54 up into two numbers where at least one of them is a perfect cube, so it can come out of the radical. And the way you could do that is, we know that 3 to the 3rd power is 27. So negative 27 times 2 is 54. When we do that, if you take negative 27 to the 1/3 power on your calculator, you can see that that's negative 3. That works. So the negative 27 is a perfect cube. When it comes out as a negative 3. The 2 is imperfect, so it's going to have to stay on the inside of the radical. And just like we did on the previous problem, x to the 9th, we're going to divide 9 by 3 and get 3. So we get x to the 3rd when it comes out of the radical. This 2 is still on the inside of the radical. So that's the only thing left on the inside. And so that's what you would type in to the answer blank. Well, let's try another one. The cubed root of 8x to the 5th. Well, give me a number that multiplied by itself 3 times gives you 8. Yeah. 2 times 2 times 2. So that means 2 to the 3rd power is 8. So the cubed root of 8 is 2. X to the 5th. Well, we divide the exponents. 5 divided by 3, well, they don't divide evenly. So kind of like what we did with the 54 up there, we're going to have to break this x to the 5th into two things, at least one of which will divide evenly by 3. And that would be x to the 3rd and x squared, because x to the 3rd times x squared is equal to x to the 5th. Now this x to the 3rd is perfect. It gets to come out. The cubed root of x to the 3rd is just x. This x to the 2nd power is imperfect, so it's going to have to stay on the inside of the radical, just like that. All right, let's try another one. All right, this one doesn't have any numbers, so hopefully it's a little bit easier. We know that when you take the square root of x squared, you just get x. And when you take the square root of x to the 6th, remember there's an invisible 2 right there, 6 divided by 2 is 3. And you'd think that's the answer, but be careful. If you remember, these are the ones where we have to make or put absolute value symbols around. Okay? When is that true? You have to put absolute value symbols around anytime you have an even exponent and an even root, and the answer has an odd exponent. So in this case, 2 and 2 are both even. The 1 on the x is odd. For the y, the 6 and the 2, the exponent and the root are both even. The answer has an odd exponent, and so you need to put absolute value symbols around your answer. Let's try another one like that. The fourth root of 256. Well, what is the fourth root of 256? I don't know either. 256 raised to the 1/4 power. Hopefully that comes out evenly. It does. It's 4. Did I show that? Yeah, 4. So that means the number part is just 4. Now here we have an even exponent and an even root. So 4 divided by 4 is 1. But be careful, because again, even exponent, even root, odd, there's a 1 here, an odd exponent on the answer. So it's the absolute value of x. So how are you going to remember when to put absolute value symbols and when not to put absolute value symbols? Here's how you do it. And I just wrote it right here for you. When do you put absolute value symbols? You put them on there when the exponent and the root are even and the answer has an odd exponent. Okay? That's the only hard part about this lesson. Let's try this one. The square root of x to the 4th y squared. Okay? X to the 4th y squared. Well, that means you're going to get 4 divided by 2, because really there's an invisible 2 here. That's x squared. 2 divided by 2 is 1. Now let me ask you this. Do either of those need absolute value symbols? Well, this one does not, because that's an even exponent. It says the answer has to have an odd exponent. But this one has an even, the y has an even exponent and an even root, has an odd exponent on the answer. So just the y needs the absolute value symbols. Okay, let's try that one. 12 divided by 3 is 4. 15 divided by 3 is 5. That's the easy part. The hard part is, do either of those need absolute value symbols? Well, this one, for the x, let's see. Even exponent, odd root. Well, it says the root has to be even. So if it has an odd root, then I don't even need to worry about absolute value symbols anymore. As soon as you see an odd root, then forget about it. You don't need any absolute value symbols. Okay? Let's go on to this one, number 8. Remember, there's an invisible 2 here, because that's the square root. So 18 divided by 2 is 9. 8 divided by 2 is 4. Do either of these need absolute value symbols? Well, you've got, in this case, you've got x to the 9th power. Let's take a look at that one. Even, even, odd. Yep, that one definitely does. How about the y? Even, even, even. So the y does not, but the x does. Just a couple more. How about this one? 6 divided by 3 is 2. 6 divided by 3 is 2. Do either of those need absolute value symbols? Well, you need absolute value symbols when the exponent and the roots are even. Well, in this case, that's true. The exponent and the root, wait a minute, that's not even, that's odd. No, again, just like number 7 up there, we don't need to worry about it because the root is odd, so you don't have to do either of those. One more. 8 divided by 4 is 2. 4 divided by 4 is 1. Do either of those need absolute values? Well, let's see. Even, even, even. Nope, don't need one there. Even, even, odd. Aha, yes you do. You do need them around the y. Okay? So, when you're doing these problems, just make sure you keep this in mind. The only time you need absolute value symbols are when the exponent and the root are even and the answer is an odd exponent. Okay, I hope that helps, and I will see you next time. Thanks for watching.